Good afternoon, everybody. Welcome to class today. Thank you for joining me. Whether you're watching live or you're watching the recording, I appreciate you tuning in and watching. Thanks for joining me today for the very first live class of the semester. I'm Mr. Ramsey, and I'm your instructor for this semester for CIS 115, Introduction to Programming and Logic. And in this course, we take a look at programming logic, the idea being that we are looking at how to solve problems with code. And we are looking at it through the lens of the Python programming language. So we will be looking at various elements of programming logic while learning Python and solving problems in Python this semester. As we're getting started here, I just want to tell you once again, welcome. I want to kind of look at the course a little bit today. I want to spend less time looking at the course and more time talking about stuff that you're going to need for Module 1. For this course in particular, since my due dates are on Thursdays and I do this live class on Tuesdays, I like to talk about the stuff that I want to talk about for the following week. So the majority of time that we're going to be spending today is going to be spent on Module 1 and talking about Module 1 stuff. But we will do just a few little housekeeping things, just a few little introductory orientation-y kind of things today. Just so we're all clear on kind of how the course works and everything. As we get into it, hopefully you're getting around the course well. If you're seeing this video, you're able to see the announcements in some form, whether it's, via the emails that they send out or via the announcements panel here. In the Blackboard course, if you've taken online courses here before at CCC, like you probably noticed that this looks really, really different. That's part of my thing in my role here in the e-learning department, right? Like one of the things that I need to do is I need to know how to use all the Blackboard updates and how to do everything with Blackboard so that I can help other faculty members here when they are running into issues or trying to use the new Blackboard updates. And so what you're looking at in this course is, for us, a future version of Blackboard, right? It's a Blackboard that you might see more and more pop up in different courses that you might be taking online. Potentially every instructor's courses would be looking like this or similar to this in about 2 years' time-ish. Right, so we are kind of on the cutting edge as far as all that goes, and I will go into student preview here just to talk about a few things here. The first thing that I want to do is draw your attention to the announcements. Right, if I was just entering this course, it will give me a little pop-up notification here on the screen and let me know, like, there are some announcements that are available to me that I have not read. You can also see we have the little number and a circle here showing me that there are some announcements here that need to be read. Just a little notification bubble like you're probably used to on your phones or whatever else you use there. So you can go there and see all the announcements. And you see right now we have 2 announcements. One was the orientation that I sent out last week. And so a big part of this is going to be watching this orientation video. I'm not going to go into a lot of the stuff that I go into in the orientation video today. I want to make sure that you all, but I do want to draw all of your attention to that just to make sure that you watch that. Right, that goes more into course navigation. That goes more into some of the other stuff that we're going to be doing in terms of how the course is kind of laid out and my expectations for you and all that kind of stuff. There is a little segment in here that I want to talk about for a few seconds here, and that's the situation with AI. Right, my little AI policy statement here, which is basically a non-policy, right? If you actually read it, because basically, like, I'm in the know, right? Like, I understand the state of things with AI. I understand how AI works. I know how all that goes, and I know that if there's one thing that AI can do well, it's programming, right? Like one of the things that we talk about in this course is that basically what we're doing with programming is that we're giving our machine instructions. So who can better understand how to provide a machine with instructions than a machine that has been trained on those instructions, right? So AI is something that, is ubiquitous nowadays. It's everywhere. I understand that, like, you can use it, and especially in courses like this, I've gotten to where I can tell, right? I can tell what AI written code looks like generally. There were a few little telltale signs there that draw my attention to it, but by and large, right? Like, if you want to think you can fool me, and because you probably can, just to get a good grade in the class, I mean, that's something that you could probably do, but at the same time, like, you won't actually learn anything, right? Which I think is more important and more valuable in terms of this course and what you get out of it, right? Because there's sort of two halves to this course, right? Like, there's this problem solving side, right? Which is sort of the hidden curriculum of this course. This idea that I'm kind of teaching you how to figure out your own problem solving strategies, right? Like, when we talk about an algorithm, one of the things that we say an algorithm is well, an algorithm is just the sequence of steps that it takes to solve a problem, right? So if an algorithm is a sequence of steps that it takes to solve a problem, then there are dozens of different ways that a problem could be solved and still solve the problem, right? Like, a lot of that's just going to depend on point of view, what an individual's comfortable with, how they view the problem versus how someone else views the problem. So one of the things that we see here, by and large, right, is this idea that your problem-solving strategies are something that it's something that needs to be honed. It's something that needs to be built. And we can do that in this sort of class via code, right? Because the idea is that we're able to look at a problem and we're able to create a functional algorithm, right? Which is just going to be the steps that it takes to solve a problem. And we're going to be able to take that from our brains to our hands and into the computer. And when it comes to how you best think about problems and how you best approach problems, that's going to be something that really is going to have to be determined by you, right? And so this is giving you sort of a safe medium that you can do some practice in that. The other half of the course is the whole programming side of it, right? Like, you're learning how to write some code. You're learning how to write some Python, to write some programs that do some stuff. So there's a lot here that's beneficial to you, that it would really help you out a lot if you were to take the time to actually try to learn some stuff instead of just running to AI. Right? There's also this understanding that AI is used in current development jobs. But the difference is between, or I should say the difference is really how AI is used in development jobs. Right? Because I have some friends who are in the industry. They're writing code for various companies, and we've talked about this, and they basically say, well, it's more augmentation than it is replacement. Right? A good programmer who knows what they're doing, who knows how to look at code and figure out what things need to happen and how things need to be implemented, and knows how to interpret it and write it. A good programmer can work a whole lot faster with AI. A bad or somebody who doesn't know how to program, putting a bad input will receive bad code that, it's not really what they want to do. But a good programmer who understands code, who understands the logic behind it, can work together with an AI to produce higher quality work in a shorter amount of time. And that's really what we're seeing. And that's one of the reasons why, among other things, right? Like we can talk about like job prospect outlook of the coding industry. It's definitely not as good today as it was, 3 or 4 years ago, right? Like we look at some of the things that we've seen, like sort of the overplaying of the boot camp sort of thing, with a lot of people thinking that they could go take like a 6-week boot camp class and then know everything that they need how to program. And so you have a lot of people that are looking for programming jobs versus, AI kind of cutting down on the programming jobs, because the jobs that used to be done by 4, 5, 6 people are now being done by 1, 2, 3 people. So, I mean, if we're being completely honest, right, the prospects aren't as good now as they were 4 years ago, but that just means that you need something that's going to help you stand out, right? You need that baseline knowledge, and you need a good portfolio, and you need to be able to articulate your understanding of code and your understanding of solving problems with code. So this is all to say that I encourage you to minimize your use of AI in this course. I encourage you to use it as little as possible. I do understand if you use it from time to time. But in terms of the long run, the further benefit that expands out larger than just the confines of this class, actually putting in the effort and actually doing the work is going to be more beneficial to you than just giving it to AI and letting it do it. Also, as you'll see, live class link. This is also where I'll be putting, I'll make another announcement after this is over with the recording. But this is something you'll see, or something very similar to this, every Tuesday, or as many Tuesdays as possible, right? Just with the nature of my job and the way things are. I'm not a full-time instructor here. I am an adjunct instructor who teaches a lot of classes now, and I work in the e-learning department, as I mentioned. The nature of that means that sometimes I can't be here every Tuesday afternoon. I'm also the esports sponsor, so if any of you are interested in playing esports, please let me know. And sometimes we have things on Tuesday afternoons, which means that I can't be here. In those events, when I can't have a live, I will have something pre-recorded for you that'll be designed to kind of help you. I like doing it live as often as possible. It gives you all the option to interact with me. You don't have to. I try to keep the interactions as low stakes as possible. That's why I do it on YouTube, right? I feel like if it's on Teams or Zoom or something like that, right, people feel obligated to turn on their mic to talk. People feel obligated to turn on their cameras. Or instructors might feel obligated to do that, because then you're just looking at a slate of names that isn't really doing anything. But on YouTube, it kind of strips away that obligation. And you can type in chat if you want. I am monitoring chat. I'm also monitoring my email and my Teams if you want to send messages in that way. If you're watching the recording and you want to send me a question, you can send it to me via, email or on Teams. And I can answer your questions that way. I try to keep the interaction possible, but keep it low stakes, as a benefit to you all. I also find it beneficial to put it on YouTube because people know YouTube, right? Like, I don't have to explain YouTube to somebody. Like, we've figured out YouTube at this point. YouTube's been around for 18 years, almost 19 years, which is kind of wild to think about, right? I think it was 2006 when the Me at the Zoo video was uploaded, which is incredibly wild to think about now. We'll be doing a demo a little bit later on in Code HS. So I'll save my talk about Code HS for just a few moments. So let's jump into some content here, shall we? And remember, to get like the orientation, lay of the land stuff, please go back, watch that orientation video that I put out last week in that announcement. That will help you out a lot, I believe. Oh, this is all kind of messed up. There we go. So some of this is covered in that first module, so I'm not going to do all of that. But I will kind of jump around and hit some high points here as we're introducing Python. And I do like to take just a couple minutes and just talk about terms, right? And I like to kind of demystify some terms. So, we can demystify the idea of a program. We can demystify the idea of an algorithm, right? Like all of these things deserve demystification as it is, right? Because they're big sounding words. They're big sounding words that, we kind of think about as like scary, right? Whenever we hear a big word, it's scary because we don't know what it means, right? And I think that's one of the things that we kind of want to talk about at this point in time is like code is challenging. But one of the big things about the challenging nature of code is that it is an unknown for many of you, for maybe all of you, right? You maybe have never written any code at all, or you're trying to, figure out some stuff for the first time here. Or maybe you've written some code and you're, actually getting some formal coding experience in this course. So it's mysterious, and when it's mysterious, when it's unknown, it can be scary, right? So one of the things that we want to keep in mind as we're kind of approaching this big topic is this idea that like anything you do for the first time, you're probably not going to be good at it, right? Like it would be unreasonable of you to expect to be good at, say, basketball if it was the first time you picked up a basketball and walked onto the court, right? It would be unreasonable of you to think you could make 10 3-pointers in a row the very first time you pick up a basketball. Some people might have beginner's luck and they can do that, but some people it's going to take practice and it's going to take experience and it's going to take time, right? And so that's one of the things that I want to kind of encourage you all with here at the beginning. Because, as we're approaching this, right, we're going to try to demystify a lot of the programming jargon and a lot of the scary stuff that is big terms around programming. And we're going to try to make it friendlier and try to make it more approachable. Because ultimately, that's what we want to do, right? We want to do something like that. Because that's going to ease us into it. And it's also to say that, we shouldn't be discouraged if we don't know something, right? Again, it's unreasonable to think you should know it all day one. I was telling somebody just the other day, they were asking me about programming and code and my thoughts on it, and I basically just told them flat out, like, I've been writing code in some form or fashion for roughly 20 years. And I will still learn things today, right? Programming is a big subject There's a lot of things to learn. There's a lot of things to know. I would argue that anyone who claims to know it all is maybe misleading a little bit, right? But, that's just sort of on a side there. Let me try to pull it back into the station here and get back to talking about what a program is, right? Because a program is a sequence of instructions that specifies how to perform a computation. There's another big word, computation, right? Or actually, we got a couple big words out of this, instructions and computation. What's an instruction and what's a computation? Well, a computation is just doing something, right? Doing something typically mathematical, right? Because really everything that we look at when it comes to a computer is mathematical. One of the big things that we try to instill in you all, right, as you're approaching this subject is this idea that computers are dumb. Computers are not smart. Computers are dumb. If you thought computers were smart, you were misled. Computers can only do exactly what we tell them to do. Right? And even more than that, I would argue that you are smarter than a computer. And I can give you my reasoning for that. Because I can show you two letters here. I can show you this letter. And I can show you this letter. And if I asked you to look at both of those letters and tell me what that letter is, you'd say, well, it's an A. We got two different A's here. We have an uppercase A and a lowercase a, but they're both A's. Right? And we can jump to these conclusions and we can work to these ends. So if I looked at a word like, say, apple, all lowercase, and I looked at a word like, say, apple with an uppercase A at the beginning of it, you'd be able to read that and you'd be able to say both of those are the word apple. A computer's not that smart. To a computer, these two things are completely different things. Right? And that's one of the big things that we want to try to approach as we are getting started with all of this. Computers don't know words. Computers don't know letters. Computers don't know any of that. What a computer knows is patterns. Right? So a word is a string of characters, and characters are made up of patterns. Specifically, a byte of patterns, or 8 bits of patterns. And that can be translated to a chart. Right? This is an ASCII table. This is how a computer can translate patterns into characters. Right? So we see here, we can do that lowercase a example there again. We have a lowercase a. And we see that it is decimal 97. Now, our computer doesn't know decimal 97 either. That's something that we'd have to deal with as a computer. Now, our uppercase A is going to be decimal 65. And so there are two different numbers that correspond to two different 8-bit patterns that make them two different things. Right? And that goes back to binary, right? The patterns that we're talking about here, they're binary. So if we were to look at that, we were to say, okay, well, uppercase A. Uppercase A, we said that relates to the value 65. And we say that that is an 8-bit binary pattern. That 65 translates to my computer in an 8-bit binary pattern. An 8-bit binary pattern is an octet. And this gets a little technical, right? Like this is something that I wouldn't really expect you to like do, but it is something that's good to know, right? So when you're looking at any number system, right? Like we're used to a decimal number system, which is base 10. It is the base of the number system raised to the power of the place. Right? So 10 to the 0, 10 to the 1, 10 squared. Right? So for base 10, it's 10 to the 0, 10, 1, 10 squared. 10 to the 0 is 1. 10 to the first is 10. 10 squared is 100. Right? So this is your ones place, your tens place, your hundreds place. So if I had a number that was like 347, so on and so forth. Binary is similar. Right? But binary is base 2, right? It's 0 and 1. So it's 2 to the 0, 2 to the 1, 2 to the 2, or 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th, 2 to the 6th, and 2 to the 7th. Now we can go past that, right? We don't have to stop there. We can go past that. But this is our 8 place values, which we call an octet. O-C-T-E-T, octet, just means 8. A group of 8. And these values correspond to 1, 2, 4, 8, 16, 32, 64, and 128. So basically, if I have a 1 in that place, I'm going to add the number place value to my overall number. If I have a 0 in that place, I'm going to skip it. So we have this A up here, this A that is 65. Whenever I'm doing my binary conversion, I usually go from left to right. So I'll start in the 128's place. And I say, is 65 minus 128 a positive number? And in this case, it is not. So that is a 0. The next one is 64. Is 65 minus 64 a positive number? In this case, it is. That's a yes. So I put a 1 here. And then I actually do that calculation. And so now I'm left with 1. So the next place is my 32. Is 1 minus 32 a positive number? No. 16. Is 1 minus 16 a positive number? No. 8. Is 1 minus 8 a positive number? No. 4. No. 2. No. 1 gets me to 0. 1 minus 1 is 0. So I can put a 1 there. So my binary representation for the letter A, the pattern that corresponds to the letter A, is 0, 1, 0, 0, 0, 0, 0, 1. Right? That's how we do that conversion. For our lowercase a, we said that was 97. Is, and I'll just go ahead and write it out here, right? Just for the sake of time. So to convert our A to binary, it's 0, 1, 1. 0, 0, 0, 0, 1. So it's easy for me to show you the decimal, right? And say, well, 97 and 65, there's, 32 numbers between both of those, right? So they're 32 off, but they're not really 32 off, right? Like that's how precise our computer is that when we look at this, we see it, well, it's not really 32 off. It's really 1 bit off, right? This 1 bit, which 1 bit is the smallest amount of memory that's available to a computer, right? 1 bit is different, right? It's a 1 where it's a 0. And so when you're writing a program and you put an uppercase A where you should have put a lowercase a, and that throws your whole program off and breaks your entire program, what's breaking there is being caused by 1 bit of memory. Which gets back to this whole idea of how dumb our computer is. Because our computer is so dumb, right? Like, if we have one little thing that's kind of weird get thrown at us, we can just kind of smooth right by it, right? This is the teeniest, tiniest part. Like, if 1 second of our whole day was kind of confusing, we could figure it out. Our computer can't do that, right? This one teeniest, tiniest bit of memory here, if it's different, then the whole house of cards falls for our computer. And that's bad. Right? So this gets to the idea that, when we're doing these calculations, we have to pay extra special close attention to these calculations. But it also shows us that everything is a calculation, right? Everything is mathematical to some degree. So whether it is, actual math that you're doing, calculations, whether it is, a video that's being played, right? Because that video just breaks down to representations of these ones and zeros based on pixels and where they're at any given time. Playing an image or showing an image, playing a song, creating an essay or a text document. They're all computations because they're all solely or eventually based on math, right? Because they're all about that George Boole inspired binary logic. And so we said that it's a sequence of instructions that perform a computation. Computation's mathematical in nature because everything breaks down to ones and zeros. What is an instruction? Would be the next thing that we would classify, right? So an instruction is a line of code. And the details of how these lines of code work out are different in every language, but they kind of break down to 5 key things, which we could also combine those to be 4 key things, right? Some people will talk about them as input, output, math, conditional execution, and repetition. So input being able to get some data from some device, right? Like your keyboard or a file or the network or whatever. Output being able to have a result. Save a new file, display data on the screen, send it out somewhere. Do mathematical operations, perform computations and calculations. Check conditions. So try to see if something is true or false, and then run some appropriate code based on that. And then repetition, the ability to do something over and over and over again without actually having to spell it all out, right? And so some people will also take these two, this math and conditional execution, and they'll put them together, right? And we'll just call that E for evaluation. We can take these 4 and put them into something that we call a REPL. Which stands for read, evaluate, print, and loop. So the input would be our read, the output would be our print, The math and our conditional execution would be our evaluate, and the repetition would be our loop. So these are two different ways you might hear somebody talk about the same thing. So I want to write some code before we go today. So I want to talk about the shebang first. So I am going to be looking for the shebang statement in every single program that you write. It will be a part of the grade, right? I'm going to be looking for this shebang statement, and if it's not there, I'll count off for it, right? And it's just sort of me being a jerk about it. Right, because this is getting to the idea that, sometimes best practices are not requirements, but they're good to do. Right? Like, I don't need a shebang statement for my code to run. I can write Python code without having to write a shebang statement, but it is a good thing to have. Because this shebang statement basically lets my computer know which environment this program should be run in. So if I double click a .py file, then it will just run, right? Because it'll know that it should be run in the Python 3 environment or the Python environment. So it's just a good best practice, right? Like, it's just a simple thing that we can include in our program that's going to make it a little more flexible. It's going to make it a little more modular, easier for other people to use. And so it's this line that we have here in the different font. Hashtag exclamation point, which is where we get the shebang from, right? The hash being the hashtag. And bang, another term for an exclamation point, is a bang. Maybe at some point you've had an English teacher or somebody give you the talk about a punctuation mark called an interrobang, which is like a combination of a question mark and an exclamation point. Right, so a exclamation point is just also known as a bang. And this line of code being in our code just tells our computer this is some Python code. If they try to execute it in the Python environment, everything will be good. Hashbang /usr/bin/env Python 3. So let's write the Python hello world, which is super simple. In order to do that, I am going to jump into CodeHS. I do recommend you all use CodeHS, just so we can kind of go through how CodeHS functions or works. Once you log into CodeHS, you'll see a screen that looks like this. You do not need a class code for this class. You are just going to use the sandbox for this class. I'm not, they have some really fancy sort of classroom applications inside of CodeHS. I'm not going to use those. You're just going to go up here to the sandbox, and that's where you're going to complete all your assignments. And so you click up here on Sandbox, it'll take you to this page. You can type a name for your program here, click Create Program, and you're just going to select Python 3. The regular old Python 3 here. And then create it. And so by default here, it just gives you the hello world. That's as simple as the hello world is, right? It's just print and then in parentheses, in quotes, hello world. This is how we can print any statement. Now we can go over a few things here while we're kind of talking about this hello world, right? So the first thing that we're going to do is I'm going to erase that. We'll write it all again. And I'm going to write my shebang, hashbang /usr/bin/env Python 3, right? And there is a space between env and Python 3 here, just so you all can kind of see that. Now, one of the things about Python, and it's something that we'll talk more about in future modules, is that it is, when we're dealing with the code itself and how the code is formatted, it is tab-based. So that's going to become more important to us when we get to, say, Module 3, right? The idea that we put in tabs to kind of define ownership. We will go ahead and mention, I don't quite remember. Let me have a quick look here. Just add our course, what you do. So for this course, you're just doing some basic mathematics for this particular lab. So one of the things that we'll want to do here is that we'll want to say, well, you know, like you can just print the results of a mathematical equation, and it'll show up in your console, right? So if I wanted to do some sort of simple mathematical equation like 24 plus 6, I run that and I get 30 on the output. If I wanted to do another task, I can just go right beneath it and do another task, right? So I can print, let's say 24 minus 6. And so now as my program executes, it's going to go from top to bottom. So it's going to do what's on line 3 here first, and then it's going to do what's on line 4. So it'll show me 30, and then it'll show me 18. Super simple. Right, and we can keep going with our basic operations, right? We can say 24 times 6 times is an asterisk. Now I did that on purpose there by adding that extra space. There are some places here where those extra spaces are not important, and there are others where they are, right? So in this case, I could put extra spaces around my operators here, or I could not. All right, I don't have to in this case, right? Because Python's smart enough to where it can pick up with or without the spaces and do my operation. However, there are some instances where the presence or lack of presence of a space is more important, and we'll consider those, talk about those more when we kind of get to them, right? Like we're starting just really, we're just kind of barely dipping our toe in the water here in Module 1. Let's go ahead and do a division problem here. And so I used 24 and 6 so we could get, you know, all whole number even values. Right, because then we have 30, 18, big number, bigger number than I'm trying to throw off the top of my head there. Somewhere along the lines of, it'd be 150 minus 6, right? So 144. Right, we can even put these out here as comments if we wanted to. If you want to write a comment to add some context to your code or what's supposed to be going on, you can just write a hashtag and it'll become an inline comment. Right, so I'm just kind of putting in here the outcomes that we should expect with this. I will share this with you all as well. All right, so we said this would be 144. And then this is 4, right? And so these are the outcomes that we should expect, right? And this is the kind of thing that I tell people to do too as they're starting to learn how to code. Right? These are problems that are simple enough to where I can do them kind of in my head and then check the answer. And then if the answer is right that I get from my output, then I know I've written my code correctly. And I can start to plug in more complex numbers that maybe I don't trust myself in terms of how well I can do that math on them, right? So we should be able to run this, see these results. There we go. We get 30, 18, 144, and 4.0. And you see that's 4.0 and not 4. And that's because we're doing division here. So Python is a loosely typed language. That's discussed in your module. It's a loosely typed language, which means that it can just understand what type of data something is, right? So if we look at a different type of programming language, like say Java, Java is a strictly typed language. So when I create a variable, say in Java, I have to make a promise to my computer that I'm making a specific type of variable. Whereas in Python, I don't have to worry about that, right? I don't have to do that. But in order to do a division problem, you need precision. And precision requires a floating point number. So it has to take and typecast, and this is something that we'll talk more about in the future, these values into floating point numbers before it can do the division. Because at its core, right, Python is just C. Right, C and C++. Or really, C. So it's taking the code that you write in Python and it's converting it to C, and then it's running that. Is really what's happening behind the scenes. And so in order for that to do division with precision, you need a floating point number or a decimal number, which is why it converts that to 4.0, right? And there are techniques that we'll talk about in the future where we can get rid of that. Right, one of them would be doing something that we call a typecast, which in Python, all we do is we take our data type and we wrap it around that equation. Which would then turn that into a whole number. Now that's something that I would only do if I knew that I didn't need the precision, because it's going to take all those numbers past the decimal and just lap them off. We'll talk about some other operators and stuff in the next module as well that are some more advanced operators. Right, this is just, sort of the basic dipping our toe in the water type module. Another thing for us to consider is that Python follows PEMDAS rules. Parentheses, exponents, multiplication, division, addition, subtraction. And remember that when we are doing PEMDAS, it looks more like this, right? We do multiplication and division together, left to right. We do addition and subtraction together, left to right. So if I were to write something like 23 plus 17 times 2, that's ambiguous, right? Based on PEMDAS rules, it's going to, as it stands, it's going to do 17 times 2 first, which is going to be 34, and then it's going to add 23 to it, making it 57, right? So if we run this now, the last number here should be 57, which it is. But what if that's not what we meant? What if we meant add these two numbers together and then take the result and multiply it by 2? Well, in that case, we simply need to wrap those numbers in parentheses. Right? That way, it's going to use our PEMDAS rules. It's going to force those parentheses to be worked first. And we're going to see a very different result, right? Because that's going to be 23 plus 17, which is 40, plus 2 should be 80, right? Which is what we get now. So two very different results when we just change the order of operations. We can do exponents as well. There is an exponent operator. We'll talk more about that in the next module, right? So if we do asterisk 2, it is multiply. If we do asterisk asterisk 2, it is squared, right? It's raised to that power. There's also something that we'll talk more about later called the modulo, which the modulo gives us the results of a division problem, which is the, let me phrase this, it gives us the remainder of a division problem. Right, so if I had, say, 12 divided by 6, right? 12 divided by 6 is 2. 6 goes into 12 evenly 2 times. If I had 12 modulo 6, which in Python a modulo is represented by a percent symbol, that's going to be 0 because it goes in there evenly. If it doesn't go in there evenly, like say 7, right? In this case, 7 goes into 12 one time and has 5 remainder. So this would be a 5. So the last number that we should see over here is 5. And so this is a way that we use to determine whether a number is even or odd, right? Because we could say basically some number modulo 2. If it's an even number, 2 is always going to go into it evenly, so the result of this would always be 0. If it's an odd number, it would be something other than 0. It would be 1, really. And at that point, we could tell it was odd. And that's something that we'll work with that more in the future as well. And so some other interesting things to talk about, and we will just kind of talk, and I'll just kind of set you up for the future. Right, there are some instances where we can use our asterisk and our plus symbol for something other than multiplication and addition. But we'll go ahead and put our hello world back in here, just so we have that as well. And you can see examples of several different things when I give you this file. Now notice here when CodeHS loaded up, it gave me the hello world in there in single quotes. I put it in double quotes. That is personal preference. Whatever you prefer. So I believe that's where I want to wrap up today. I think that's what I have for you for today. There are some other videos and things of that nature in the module to help support you. We'll hang out and chat just a minute now, just in case anybody who's here with me live has any questions. If you're watching the recording, feel free to send me any questions that you might have via Teams or via email. I'll be posting the recording of this along with this CodeHS file in an announcement once we're done here. This is a good time to point out that what you'd want to send me with this CodeHS file is just the URL here. So whenever you're ready to send something in for an assignment, you can just go up here, highlight the URL, copy that, and then paste that into Blackboard. So if I were to look at Blackboard, which is here, I'm still in student preview. I'd go down to, well, it's sequence. So since it is sequence, I do have to work through the sequence. I'll work through the sequence while you're thinking of questions if you have any questions. This video here is a little more complex. It's about twos, complements, and bitwise operators. I don't test you on any of that, but it is good stuff to know about. Just kind of as we're going through there. Real good computer sciencey type stuff. So when you get here, right, when you get to the lab and you're ready to submit, you've viewed the instructions, you see what you need to do, right? You can just click in this box here, paste in your URL, and submit that. And then you're good to go. And I can click that from there and open it up, or just drag it over in my browser window and have a look at it. I'll discard all that. So with that being said, seeing no questions in the chat, we will go ahead and wrap up here for today. If you think of any questions later, or you're watching the recording and you have any questions, please send me an email or Teams message and let me know. That is all that I have for you for today. Thank you for watching, and we'll see you next time.